Hey boys and girls, it's Miss Williams again, and this time I'm here to show you some division strategies because we have moved on to division of larger numbers. So most of you may be getting some help from your parents, and your parents will be teaching you the standard algorithm, which is probably the way they learned it when they went to school, and you can use that strategy. You'll be learning more about it in 5th grade. But we do also want you to learn some of the strategies that we'll be doing in class because they're part of your standards and you will be tested in that way also. So we want you to know lots of different ways. All right, so let's get started. Okay, so we're going to look at this word problem to kind of get us started. It says a coach ordered 6 soccer goals for $678. How much did each goal cost? So remember, like we do in class, the first thing we have to do is we have to make sure that we understand the problem. Okay? So let's think about this. Okay, so we know that the coach ordered 6 soccer goals. So we're talking about the goals used in soccer to score at the ends of each side of the field. And the coach paid $678. Now, we can use our common sense. I don't think the coach paid $678 for each goal, although they may be expensive. But it says here he ordered 6 goals for $678. So $678 seems to be the total for the goals. And the question is, how much did each goal cost? So we're trying to find the cost of each goal. Okay, that means each goal cannot cost $678. That's the total. So the way I like to think of it is $678 is the total amount that was spent. Okay, and I know that 6 goals were ordered. So I'm going to just draw a little model of 6 goals. This is kind of the way a goal looks. Okay, and I do not know how much each goal cost because that is the question I'm trying to solve. But I do know that it was paid for with this money. Okay, so 6 goals for $678. How much did each goal cost? Just by looking at the picture, I can already tell that this is a division problem, and this is why we draw pictures, boys and girls, to get an idea of what we need to do to solve. So I know that I have to take 678 and break it up into 6 parts. Notice I said break it up, which is the same as divide it up into 6 parts. So I'll be doing 678 divided by 6 equals some number, okay? How much did each goal cost? So let's just say n for the missing part. Okay, you guys know that in class we use a variable for the missing part. All right, so one thing I can do to solve this is I can take 678 and break it up into 6 parts. So I'm just going to make 6 circles. Okay, like I said, boys and girls, your parents may be teaching you a step-by-step way to divide called long division, and it's okay to do it that way too, but again, these are some strategies that that I would also like you to learn and get used to for 4th grade. In 5th grade, you will definitely be doing long division the regular way, and this is just one strategy that I'm teaching you now, and I will be teaching others soon. Okay, so let's think of how we can break apart this amount into these 6 equal parts. Okay, so we just have to start using our common sense and work with friendly numbers. So, for example, in class, we've been working with small friendly numbers like 10. So if I put 10 here, 10 here, 10, 10, 10, and 10, that's going to be 60, but I still have such a long way to go because the number is 678. So maybe I need to bump it up to a much higher number, but still a friendly number. So I'm actually thinking that because the first digit is a 6 and that represents 600, that maybe I can give 100 to each group, and that will actually take away the whole 600. So let me just try that. Okay, so I know that 100, 100, 100, 100, 100, 100 equals 600. So I already took out 600 from there. So I'm actually going to rewrite it here and keep track of that. I'm taking away 600 because I already used them in the 6th group. So that leaves me 78, which is a much easier number, smaller number to work with. Okay, so now again, I have to think, how can I break apart 78 equally into 6 groups? So now I'm thinking 10 might be good because 10 6 times will be 60, and that's getting down to a lower number. So let's try 10, 10, 10, 10, 10, and 10, and again that equals 60. I'm going to take it away and see how much money is left. Remember, this represents money. So, ooh, now I have $18 left. So if you know your times tables well and your basic facts, you should know that 6 times 3 equals 18. And since I have 6 groups, if I give 3 to each group, that will equal 18, and I'm down to $0. So that means I broke apart all $678 into 6 groups. My 6 groups are really representing my goals. So go back to the question. The question was, how much did each goal cost? All I have to do is look at one goal, because this circle represents one of these, a goal, and I add up all the parts that are in there, which are actually called partial quotients. We'll be learning that soon. And I can just pretty much add it right there. 100 plus 10 is 110, plus 3 more is 113. So that is my answer, boys and girls. N equals 113. And the question was, how much did each goal cost? This is actually money. So my answer should be in money form. Okay? All right, let's take a quick look. So hopefully that made sense. And if you look, boys and girls, all we did was work with friendly numbers, which we do a lot in class. So this should not be very difficult for you. And again, we will be using other strategies very soon, but they're all kind of related to friendly numbers. Let's try another problem. Okay, now this one, we're going to see something different happen in this problem. This says Mitzi has 38 coins. She shares the coins equally among her 3 brothers. How many coins does each brother get? Okay, so again, important information is that we have someone with 38 coins. She shares, that's a pretty important word, the coins equally. This is really important too. That means everybody should get the same amount. Nobody should get more or less. And we have 3 brothers that are going to equally get those coins. And the question is, how many coins, that's going to be my answer, in coins, does each, really important, each brother get? Okay, so kind of the same idea. I know that my starting number is 38. 38 coins, okay? We can't go past 38 because that's all Mitzi has, 38. So sometimes, boys and girls, you might see a problem like this and you're not really thinking about what's happening in the problem, and you decide to just multiply. If you multiply 38 3 times, 38 times 3, you're going to get a very large number, and that would not make sense when the question says, how many coins does each brother get? How can each brother get a big number like 100 coins when there's only 38 coins to start with? So think of this as your total. Again, I'm going to go ahead and represent those 3 brothers by just making some happy faces. So there's brother 1, brother 2, brother 3. And I know I'm going to be giving coins to them. So like 1 coin for you, 1 coin for you, 1 coin for you. And I would just keep going until all 38 coins run out. But I have to remember that the amounts have to be equal. Okay? So once again, and again, boys and girls, I could give 1 coin to each person and just keep going till I reach 38. There is nothing wrong with doing that. That is a really good strategy to do, but it could take you a little long. So what we're going to do is we're going to go ahead and try to divide. I know it's division because I can see what's happening here. I'm breaking apart the 38 into 3 groups, and I'm trying to get a final answer. How many coins? Maybe C for coins. Okay? Okay, so now that I'm sure that it's division, I'm going to go ahead again and make 3 big groups. These groups represent the 3 brothers. Okay, but I want to make my circles nice and big so I can fit coins in there, little models of coins. And again, boys and girls, I could go 1, 2, 3, 4, 5, and make little dots or little marks or tallies inside each one. But instead, I'm going to want to work with friendly numbers again. So I have to really think, 38. How can I start breaking apart 38 into friendly numbers? Okay. A good number to always start with is 10. If 10 is really low, you could jump all the way up to 100. If that's too high, then you start picking some friendly numbers in between, like 50 or 20. And if 100's too low, you can jump all the way up to 1,000. And the idea is that you want to always work with friendly numbers. So let's start with 10. If I put 10 there, 10 there, 10 there, that's going to be 30 coins already. 10 coins, 10 coins, 10 coins, that's 30 coins. That means only 8 coins will be left. So I think that's actually really good. So 10 coins for each brother. I know I started with 38 coins, or Mitzi started. Take away the 30 coins that have already been given to her brothers. She has 8 coins left. So the problem I see here is that I don't think 8 will break apart equally into 3 groups. I can try 2, 2, 2, 2. That makes 6. That's going to leave 2 coins. Let's try 3. 3, 3, and 3. That's 9. I don't have 9 coins left. I only have 8. So it looks, boys and girls, like I'm going to have to give each brother 2 coins because that's all I have enough for. So 2, 4, 6. Let me take away those 6 coins. And now I have 2 coins left. I have to ask myself, can I share 2 coins equally with 3 people? I cannot, and I cannot give 1 coin to him, 1 coin to him, and then nothing to him. That would not be equal groups. So what happens here? We have a leftover number, or in math we call that our remainder. Okay, so in this case, let's go back to the question. How many coins does each brother get? Well, let's look at one brother. Here's one brother. He gets 12 coins because I know 10 and 2 make 12. So each brother, I can also put this in a complete sentence, gets 12 coins, and 2 coins will be left over. And that would be a complete way to write your answer. If you write your answer in a number sentence or equation, your answer would be 12, remainder 2. So we've already done a little bit of this in class, boys and girls, but mostly we have worked with place value blocks and models, 10s and 1s, and now we're actually starting to go past that and think about all the friendly numbers we know. Okay, so boys and girls, I hope this helps. I will be showing you some other strategies for division, but this is a nice, easy way to start, and I think you would do really well with this. All right, so good luck dividing, boys and girls. Bye.